this week. Before I start talking about loops, I would like to finish the final few topics about selections. The first one, I would like to talk about what I meant by Boolean conditions being general versus specific. Let's review what we knew already from last week. So if you compare two Boolean conditions or more, they overlap if they can evaluate to true simultaneously given some input value. Let's say we have a marks variable over here, numerical marks, let's say integer for simplicity. And then you have these two Boolean conditions over here. You got marks larger than or equal to 80 and also larger than or equal to 70. Do these two conditions overlap? You can try to visualize like how we did it last week. They do overlap. However, we want to say a little bit more about why they overlap. Well, let's see why they overlap. Because all the values starting from 80 and onwards, they will actually satisfy both conditions. That's quite easy to verify, right? Now, I would like to speak a little bit more, dive deeper into these two conditions by saying that one of them is actually said to be more general because it can cover more values, as opposed to the other conditions being more specific because they cover less values. So that's something I would like to say. And then we can apply this notion about general versus specific in the context of selective statements. That's something we'll do today. All right, so now I'm going to switch to iPad, and then you can see on the slides, I really try to demonstrate, give you some intuition about what I just said. And then, but it's always important to get it first intuition right. Let me now switch to iPad, and then let's see how we can understand these two conditions more visually. So we got these two conditions here, larger than or equal to 80, and then you can see that will be the pink one over here. All the values starting from 80 on onwards will satisfy this condition over here. And also we got larger than or equal to 70. All the values starting from 70 and onwards will satisfy this Boolean condition. So now, just by looking at the two bars over here, the pink one and the green one, you can see easily the size of the bar, right? You can see apparently the green ones is actually strictly larger than the pink one. So we would say the larger one that actually can accommodate more values that can evaluate to true would be the more general one. Okay, you can think about over here. You can see the green one over here is actually more general because it has more satisfying values. Okay, and on the other hand, we'd say the pink one over here is actually more specific, for the reason that it actually got fewer or less satisfying values. And we can also be more precise over here. You can see, so what exactly are the values that that can satisfy the green but cannot satisfy the pink, right? That's another question. You can see very easily that starting from 70 all the way to 79, right? Excluding 80, right? Because 80 can also satisfy the pink. So this will be from 70 all the way to 79. So these are the values that wouldn't actually satisfy the pink one, but it will satisfy the green one. Let's now try to draw another kind of diagram. It's more like a drawing the set. Okay. One way you can think about is to really turn each Boolean condition into its set of satisfying values. Each Boolean condition you're given, you want to somehow visualize by drawing its set of satisfying values. And then you want to compare which set is bigger, or the set might just be equally large. So this is really the guiding principle for you to decide. Okay, so there'll be the Boolean condition you're given, and you simply just draw the corresponding set of satisfying values. Okay, so that's a guiding principle. So now if you try to turn these two conditions over here into sets, we know that already this one is going to be strictly smaller. It's going to be all the values starting from 80. So it's going to be 80, 81, 82, right? Conceptually all the way to plus infinity. All right, and then you can see that this larger one over here, this Boolean condition here, is said to be more general because it can accommodate not only the values that will be here, but also some additional ones. For example, you can see what we just said. It's going to be from 70 to 79. So 70, 71, 72, all the way to 79. So these values will satisfy the more general condition, but they will not satisfy the more specific conditions. On the other hand, all the values that will satisfy the specific conditions here is guaranteed. Those will also satisfy the more general conditions, right? That's kind of the property you want to get used to. All right. So now, hopefully, now you got an intuition between the general versus specific conditions, right? I just remind you over here, one is more general and one is more specific, and you will only compare multiple or two Boolean conditions if they really involve the same variable. If they don't involve the same variable, there's no point to compare them, right? All right. So that's about general versus specific. I hope you got an idea. Let's go back to the slides. You got just another example over here about 65 versus 75, right? You can see, again, it's the same variable marks and marks over here. I'll leave you to read the slides to determine which one is more general and which one is actually more specific. I'll leave you with that, all right? And then if you got any trouble, you can speak to me or maybe rewatch what I just explained previously. All right, let's now go on to another example over here. Now that we know how to determine, let's say, two Boolean conditions, let's just make it a little bit more restricted rather than comparing more than two Boolean conditions. Given two Boolean conditions here, once we know which one is more general and which one is more specific, they do have an impact when they are used for branching conditions for selections. So let's see how exactly they might impact. Let's do just another two Boolean condition. Can you see which one is more general and which one is more specific? Hopefully you can tell, right? So what values can make both conditions true? Number one, they actually overlap for sure, right? So what values can really make both conditions true at the same time, right? Think about it before I show to you. Well, basically all the values starting from 5, 6, 7. And you can think about all these values will guarantee to satisfy this particular condition over here, which is more specific. On the other hand, this more general condition over here is actually going to have some values satisfying it, but those values cannot be used to actually satisfy this. For example, what about the value just 1, right? If you try x is equal to 1, 1 larger than or equal to 0 will be true. However, 1 larger than or equal to 5 will not be true. All right, so I'm just trying to explain this verbally, but hopefully you got the idea from the previous illustration over here. You can try to draw the same diagram, especially this circle diagram over here, to see which set is actually bigger. Then you will see exactly what I meant. Okay, I'll leave that exercise to you. It's rather simple. All right, and then we can see which one is more general and which one is more specific, right? Apparently this one is more general. All right, so now I'm going to apply these two conditions, general versus specific, into selections, and let's see how we can reason about them. Okay, let me switch to iPad again. Okay, so this is kind of like a solution to the exercise I just wanted you to do, right? Just about these two Boolean condition, right? X larger than or equal to 0 is a bigger circle over here, and this is the more specific Boolean condition correspond to the strictly smaller circle. All right, I'll leave that to you. Okay. And now what we want to see is, let's say we got a single if statements. We got two versions over here. Version number 1, okay, is a single if statements, and then we put the more specific condition first. Okay, let me just write it down just to remind you. So we got two versions over here. You can think about this one is the more specific Boolean condition. So that would be the first branching condition. Okay. On the other hand, if you look at the second version over here, okay, let me just write make it more explicit for you. This is version number 1. This is version number 2. And for version number 2, the more general version is actually used as the first branching condition. More general. All right. And now the question is, will there be any differences at the runtime between these two versions over here? For example, given any inputs, are we going to get just the same output? You can see the output will be either larger than or equal to 5 or larger than or equal to 0. But we simply just put it in the reverse order. But we want to know whether these two versions, 1 versus 2, will actually give you the same output. So yes or no? All right, the answer is no. They are not going to give us the same output. Let's see why. Okay, I'll simply just use one value over here to illustrate. let's see, x is equal to 5. Let's say use this input value over here. I wouldn't use debugger for this simple example. I'll use debugger for another slightly more complicated example. Okay, but for this one, just for introduction. Let's say if the value for x is simply 5, right? 5, if you look at the number line over here, 5 is actually around over here. It's going to satisfy both the specific and also the general. Agree? Because these two conditions actually overlap. So this is actually when x is equal to 5. Let's understand where it is in the number line. So that means the blue one is going to satisfy this and this. And it's also going to satisfy this and this. And remember, this is a single if statement. That's the critical point you want to pay attention to. Let me highlight it just to emphasize that. It's a single if statement, meaning that we will never actually execute more than one branches. Whichever the first one got its branching condition satisfied, we're going to execute it, right? So now we want to see which one will get satisfied first, and then we execute that branch. Let's try to run this value over here. Let's say 5. So now 5 larger than or equal to 5 is actually true. So we're going to execute this. So the output to the console is simply just going to be x larger than or equal to 5. And then the else if part was simply just bypass, right? It's really important to see that once the first branching condition is actually satisfied, in this case, the more specific one, because it's arranged to be the first one. So the else if part is simply bypassed. And we're going to see a symmetric occurrence in the next one. Let's say we still try the same value over here. And let's say we'll try this. 5 larger than or equal to 0 is also going to be true. However, this time this output is going to be produced. X larger than or equal to 0, right? And then the rest of the if statement is going to be bypassed. Hopefully, so far you're following me, right? So now, why are they different? The reason is it's a single if statements, number one, so only the very first satisfying branch will be satisfied, number one. Number two, the first branching condition in this case is the more specific condition. And in the second version, the branching condition is the more general condition. However, since these two conditions actually overlap on many values, so that's why they will both be satisfied, either this one here or this one here. However, the corresponding output is simply different. Okay, so that's why in your slides it will simply say these two programs are actually different. Okay, even though they are using the same branching condition, but they are arranged in a different way. However, as a small exercise you can try, if you simply get rid of the else over here, their behavior will be slightly closer, in the sense that it's going to print out both in both versions. However, the order of printing will be also different, right? That's a slide exercise you can try yourself. All right, let's go back to the slides. I think that's enough. So what's the lesson learned from this page over here? The lesson learned is, if you only got a single if statement over here, and then the conditions are actually overlapping for the branches, then you got to be careful about ordering them. If you go from specific to general, you might have one kind of behavior. If you go from general to specific, you just got another kind of behavior. They will just be different. And which one do you really need? I will illustrate that with another example. You should really go for the more specific to the more general one, typically. Okay, I'll give you one example to justify that. Let's go back to the slides over here. Okay, so that's exactly what I just said to explain why it will actually be a different behavior. You can read the slides. You already gained the intuition from my explanation on the iPad. And then this part over here is really important. The cost for the not specific enough problem for the second program, which is this one here. You can see for this one here, we are actually getting this one here to be satisfied, but this one is way too general somehow. So we will rather for the first satisfying branch to be as specific as possible for that particular input value. That's what we will like. Okay, you can take a look at this description over here, right? And let's now take a look at another example, and then I'll use the debugger to really show you how exactly it will run. Let's now take a look at this program over here. Okay. what I want you to do is, before I try to start explaining about the problem for this example here, that's why I say it's a common error over here. It's a very common logical error for you to make. This program here will compile, no problem. However, the behavior could be very weird or very hilarious. Let's see. We got this condition here, one branching condition, 2, and also 3, and also 4. We got 4 branching conditions over here. They overlap, first of all. Okay, you can, for example, I can simply got, let's say the value of, let's say 5. If you try the GPA, let's say, there's no GPA 5, beg your pardon. Let's say 4.6, okay? If I got GPA 4.6, in that case, it's going to satisfy this, satisfy that, and also satisfy that. Agree? Okay, let's say 4.6, right? It's one of the value that can satisfy all the conditions simultaneously. And are we arranging the branching conditions from the most specific first or most general first? That's something you want to ask yourself as well. Okay, I'm going to visualize that in front of you, and then we'll see what's wrong with this program over here, and we'll see how to fix it. Okay, so now this is the program we just look at. Let's now take a look at which one is actually how the branching conditions are actually arranged. So the first one we got is GPA larger than or equal to 2.5. Larger than or equal to 2.5. Right? It's pretty general, I would say, pretty wide range. And then the second one is larger than or equal to 3.5. So you can see that one is more specific, slightly more specific, right? You can see there's some value over here that will satisfy the yellow, but it wouldn't satisfy the green. That's why the yellow is more general than the green. Or symmetrically, the green will be more specific than the yellow. All right, let's see the next two very quickly. And what about larger than or equal to 4? In that case, you're going to get this even more specific Boolean condition here. And what about the pink? Larger than or equal to 4.5 is going to be the most specific one, right? You can see the way we sort the branching condition over here, right? The way we should say the branching condition sorted from most general. Most general is basically the yellow one, right? This one over here, to most specific. In this case, is the pink one. Okay, most specific. Okay, exactly over here. All right, and what's wrong with this? Let's just run on the paper very quickly. See what. Let's see what's going on. Let's say if I try 4.8 or 4.6, which I said when I went over the slide with you. If I try 4.8, 4.8 larger than or equal to 2.5 is going to be true. Meaning that we're actually going to say the student is going to graduate with a pass, right? This is actually true, but it's not accurate enough, right? To be really accurate, to be as accurate as possible, you really want to make sure the first satisfying branching condition is the most specific possible, right? So it's going to simply say pass, and then now the question is, are we going to check other branches? The answer is no, because this is a single if statement over here, right? It's always important to see to really understand the context that we are talking about. You can think about the whole thing over here is a single if statement. A single if statement. And then we already satisfied the very first branching condition over here. We already satisfied that, and that one is executed. So that means the rest will just simply be bypassed. We wouldn't go any further. So the student will even though they achieve very high GPA, but they only got a pass. Again, we can say that intuitively it is true, it is correct. Okay, let me just not say true. You might just get confused with the Boolean. Let's say correct, not accurate enough, but inaccurate. So this is a very common logical error, just about how you arrange the branching conditions. If you simply just try the most general first, the most general in the sense that many values might just satisfy this right away without getting the opportunity to get further to maybe the more specific branching condition, because we're talking about a single if statement. All right, let me just do one more illustration over here to really show to you, and then I'll show you very quickly how to fix it. How to fix it? Easy. You simply just want to rearrange the branching condition from the most specific to the most general. That's what you will do. All right, let's now try this very quickly. I will simply just go to Eclipse over here. If you look at under lecture 02 selections, and then click on the common error most general condition first, right? Click on that class over there, and then we're gonna try this value over here, right? Exactly the same as I said. And then I'm gonna put the breakpoint over here. Let's say line number 8. Okay, put a breakpoint there, and then I'm gonna debug this program. Okay, let me switch to debug perspective, and then okay. Sometimes the line is not really show correctly sometimes, but that's okay. You just gotta click your mouse, click the cursor away around, and then you will be fine. Okay, so now we are right before executing line number 8. So I'm gonna say step over. So that was to enter your GPA value on the console here. Let's say 4.8 as we just set on the iPad. Enter. Okay, and then enter is going, and then we're gonna say step over to execute line number 9 to read it. Right, we want to read the next double. If I say step over, so now you can see GPA is 4.8 over here. Let's predict what's going to happen. But before I do that, you can see there's a string variable called graduate width. And then if I say step over, initially graduate width is simply empty string. But I'm expecting to reassign that to some appropriate, the most accurate value. That's what I expect to do. All right, we can see right away, go to expressions over here. Let me remove all the previous expressions from other projects. Okay, let me see. Okay, what I want to do is, why don't I just try this one very quickly? GPA larger than or equal to 2.5, copy it and paste it over here. That one is true. And also, what about the second one? Copy it, paste it, also true. What about the third one? Copy it and paste it, also true. The fourth one, copy it and also paste it. All of them are true, right? And this is a single if statement, meaning that the very first satisfying branch will be executed. And the first one here is already satisfied. So now if I say step over, is going to go into that branch, line 13. And now, after executing this, okay, so now I'm at the end of this satisfying branch. Am I going to check line number 15? Or am I going to basically go out of the current if statement and go to line number 25? It should be line 25, right? If I say step over, you go to line 25, because the rest, as I said before on the paper, they should be bypassed. It's a single if statement, right? We kept emphasizing this point since 2 weeks ago. All right, let's stop it. Okay, and then let's go back to Java perspective. That's enough illustration for you. All right, so that's about what's wrong with this program over here. The problem really is if you actually try to organize from the most general to the most, if you try to go from the most general to the most specific, that will be the common error. How do we fix it? Reverse the order. Okay, what you will do is you want to always sort the branching condition such that the most specific one comes first before the more general conditions. That's the principle over here, right? So this example, hopefully you already got the idea. And now let me just show you very quickly. Okay, actually now on my iPad, if you just go back to the slides, right? So this will be the fixed version over here. The fixed version will be, this is the most specific one. Remember, larger than or equal to 4.5 is the most specific one over here. And then go with orange, larger than or equal to 4.0, so that, for example, so now if I try, you can try different values over here. So now if you try 4.6, it's going to make sure it will satisfy the most accurate possible. If you try, for example, 4.2, you will also satisfy the most accurate possible. If you try, let's say, 3.7, it's also going to satisfy the most accurate possible over here, right? If you try, let's say, 2.6, well, of course, you will make sure it's satisfy the most accurate possible, right? So you can try the different values to make sure. All right, so that's about this particular discussion about the overlapping conditions, which one being more specific and which one being more general. Especially when you're using them as branching conditions for a single if statement, you have to always sort from the most specific to the most general one. So that's a lesson we learned from this part of the lecture.